Hello, welcome back to another video on derivatives. In this video we're going to talk about implicit differentiation. So what's the difference between implicit differentiation and just normal differentiation? Let's take a look at two different types of functions. We have explicit and implicit. Here's an example of an implicit function. We have x squared plus y squared equals 25. Now you might recognize this as the equation of a circle where you have a radius of 5. So here's our circle here. Now how can I make this explicit? Well, to make it explicit, what you would do is you would solve for y. You're writing the equation explicitly for y, solving it explicitly for y, and we get something like this. So you would subtract both sides by x squared. Right? You can solve for this, and you'd get y squared equals 25 minus x squared, and then you'd square root both sides. So you know what I'm talking about. Now when you actually graph this, you get the upper half, because you would actually have this plus minus when you square root both sides, but that's not really a big deal at the moment. All I wanted you to see was that these two are actually representing the same thing, which is the circle. So explicit means that y is by itself, this y right here, solved for y. So many functions can be turned into implicit functions. So let's take a look at these two. We have y equals 2x plus 1. That's explicit because we've solved for y. Implicit would be when y is kind of floating around in the equation. All I have to do is subtract 2x from both sides, and I've turned this explicit function into an implicit function. Alright, if I had y equals 1 over x, alright, that's explicit. I know what y is. Over here, if I were actually bring this x up with the y, then I'd get xy equals 1. This would be implicit because I have not solved for y. So explicit, we know what y is. We've solved for it. Where implicit, y is kind of floating around and it has not been solved for. So what's the point? Here's an example of a function that is implicit but cannot be turned into an explicit. Alright, there's no way we can solve for y here. So we need a way to find slopes on this, and that's what implicit differentiation does. So let's take a look at this function here. How do I differentiate x cubed? We've done it plenty of times. That's 3x squared. All right, because I'm taking the derivative with respect to x of x cubed. Well, what if I wanted the derivative of u cubed? Well, u is not x. Right? It could be a function of x. So what we would have done in chain rule, using the chain rule, was we would have written it as 3u squared, but then you would multiply by u prime, because we don't know what u is, and since it's with respect to x, you can also rewrite this as du dx. Alright, how about the derivative of y cubed with respect to x? Very similar. It's going to be 3y squared, but then you're going to multiply by that y prime. So all we're doing is the chain rule. Let's go ahead and try a couple more. The derivative of cosine of x cubed, well, that's negative sine of x cubed times the derivative of x cubed, which is 3x squared. Alright, the derivative of cosine of u cubed, well, it's going to be negative sine of u cubed times the derivative of u cubed, which was 3u squared, but then times u prime, because again, we're taking the derivative with respect to x. And then the derivative of cosine of y cubed, very similar. It's going to be negative sine of y cubed times 3y squared times y prime. Now remember that this y prime, that's a derivative. All right? That's how we've been using y prime in the previous videos. It represented the derivative. And note that y prime is also dy dx, which is another notation that we've been using for the derivative. So let's go back to this here. We have the upper half of this circle. Now let's say I wanted to know the slope at this point right there, which is the point 3, 4. Same thing over here, it's the point 3, 4. So how do I find the slope? Over here, what I would have done is I would have found y prime by just differentiating this. Over here, I'm not quite sure what I'm supposed to do. So what I'm going to do is I'm going to differentiate like I normally do with respect to x, but then I'm going to solve for y prime. So let's go ahead and do that now. Okay, before taking the derivative, we should rewrite this as 25 minus x squared to the 1/2 so that I can do the chain rule. Now when I take the derivative, y becomes y prime, and then this would be a power rule, so you'd bring down the 1/2 out front, you'd leave the inside alone, subtract 1 off the exponent, so 1/2 minus 1 is negative 1/2, and then you multiply by the derivative of the inside. Derivative of 25, 0. Derivative of negative x squared, negative 2x. All right, and I can simplify this a little bit. Notice that I can cancel the 1/2 and 2. So I'm going to get a negative x 25 minus x squared to the negative 1/2. So that's my derivative. So if you go back to the question, I wanted to know the slope at 3, 4. Well, there is my x value, right? X value is 3. So then what I'm going to do is plug in 3. So slope at 3, 4 would be y prime equals, so that's going to be negative 3, 25 minus 3 squared to the negative 1/2. And then you just got to be careful plugging this in. All right, 25 minus 9 to the negative 1/2. That's negative 3, 16 to the negative 1/2. Now, be very careful. 16 to the negative 1/2 is actually 1/4. Okay, so try that, plug it in the calculator, see what you get. But we're going to get negative 3/4. So that's the slope at that point. Let's go ahead and do it with the implicit. So my goal here is to solve for y prime. So what's the derivative of x squared with respect to x? Well, 2x. What's the derivative of y squared with respect to x? Well, 2y. But then remember, you've got to multiply by y prime because it is a chain rule. And then you move on. You got the derivative of 25, which is just going to be 0. So now I'm just going to solve for y prime. Very simple. So I'm going to subtract 2x from both sides. So I'm going to get 2y times our y prime. Notice I'm doing it in a different color because it'll be easier for me to solve for and keep track of my y primes. You'll see it in later videos why I do this. All right, negative 2x, and then I'm going to divide both sides by 2y. And that's going to leave me y prime equals, and notice that the 2's cancel and you're going to get negative x over y. Well, remember, what was x? X was 3 and y was 4. So when I plug in x is 3 and y is 4, I get negative 3/4, which is exactly what we get when I do it with the explicit differentiation. So my slope here is negative 3/4. And we did it both ways. Alright, so here's some of the easier examples. What I want you to do is I want you to solve for y prime by differentiating all the terms. And to find the solutions to these problems, more information about NIU, please visit the link found down below. Good luck.